All right, it's Mr. Richards here, and I'm going to talk about the scientific method. And what I'm going to try to do is include the things that confused me and the things that I wish my teachers would have told me when I was learning about the scientific method, because this was kind of confusing to me. And I'm going to try to make this as unconfusing as I possibly can. So the first thing that you need to know about the scientific method and just science in general is that it's really all about relationships. Not relationships between people, although, there is such a thing as psychology, which is basically that. But it's relationships between things or events, all right? And, you know, the most basic relationship is what happens to something when you do something to it, or what happens when, you change one thing, what happens to something else, okay? And, when we're looking at how things interact with each other, we're really looking at what the relationship is, okay? And so here's an example that you've probably heard a lot before, but like, what's the relationship between the sun and plants, or the amount of sun and plant growth? All right, remember, it's a relationship. On one hand we have the sun, on the other hand we have, a plant, and we're trying to see, if we have more sun, what happens to that plant? Does it grow more? Does it grow less? Does it die? We're really looking at a relationship. And the thing I want you to understand about this is that we can talk about relationships in a lot of different ways. And in the past, you probably had teachers that talked about like a testable question. And a testable question and a hypothesis are really just a way of laying out what is the relationship that you're looking at and what do you think is going to happen in that relationship. So, for example, how does the temperature at night affect the color of tree leaves? We've got a testable question, right? How does one thing affect something else? And the two things we're looking at is going to be the temperature at night and the color of tree leaves, all right? Or just temperature and tree leaves in general. And so again, remember, it's all about relationships. Okay, so here's a scientific method that I wrote down based on a lot of the scientific method steps that I found online, and it has 6 steps in it. It starts with ask a question, it ends with communicate your results. And my goal here isn't to make you remember all 6 steps. My goal here is to get you to understand the idea of the scientific method. And the idea of the scientific method is just how do you get from a question to an answer? Okay, that's all it is. How do we ask a question and then get to an answer? Now, you'll notice that the first step is ask a question. After you ask a question, remember that question is probably going to be about a relationship between two or more things. The next thing you're going to do is do some research. We have the internet now. It's really fast to ask a question, do some research, and actually get to a question. And that means that you can skip the hypothesis experiment steps and just jump right to a conclusion based on the information that you find. Now the thing is, sometimes it's more fun or more useful for your learning to actually go through and do that experiment, even if we already know what the answer is going to be, right? So let's take the example that I have on this previous slide about the effect of using real versus fake bait while fishing. And this is a question that I could look up online and find tons of information for, but it's the kind of experience or experiment that would be kind of fun to do on my own because I'd be going out and doing something I really like doing, which is fishing. So I asked a question already: what works better, or what's the relationship between real and fake bait, and how much fish I catch? I could do some research and see what other people have found. I'll probably find a lot of answers, but again, remember, I'm just going to do this experiment because I want to. And I might make the hypothesis that real baits, like actual live worms or leeches or minnows or whatever, are going to be more useful or more effective at catching fish. All right. Then I go out and do the experiment. And when I'm doing the experiment, I'm going to want to collect some data, whether that's pictures, whether that's writing things down, or maybe it's just keeping in mind like, hey, I caught 6 fish today using real bait, and yesterday I caught none when I was using fake bait. Okay, that's some data right there. Then you can make a conclusion, and then finally, the last thing you do is communicate your results. And communication can mean posting online, making a video. If you're a real scientist, you'd be publishing your information in a journal or whatever. All right, so this is a scientific method, all right, and it has generally these steps to it. But remember, the core idea of the scientific method is just the way that you go from question to answer. The last thing I want to show you is that when I was looking online, I just typed in Google the scientific method, and I found all sorts of different graphics, and they look, sometimes they look really different from each other, sometimes they look really similar, sometimes they use different words. In general, they have between 5 and 7 steps listed, and usually somewhere in there there's a question, and somewhere in there is a conclusion. So if you see those two things, question, we got question here, 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 and here, and then you also see conclusion, 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 conclusion. If you see those two things, question and conclusion, you're probably looking at the scientific method, no matter what the other stuff is in here. So just remember that. Remember, at the core, the scientific method is looking at the relationship between two or more things, and it's the way you go from a question to an answer or a question to a conclusion.